Hello students, Sacred Heart High School welcomes you all. Today we will study Standard 8, Chapter 5, Inside an Atom. In Chapter 4, we studied that atom is the smallest fundamental unit. It is the smallest particle of an element which maintain its chemical identity in all the physical and chemical conditions. Molecules are formed from atoms. Molecules are formed by chemical combination of atoms. The concept of atom is more than 2500 years old. However, it was forgotten in the course of time. In the modern times, scientists on the basis of experiments explained the nature of atom as well as the internal structure of atom. It started with Dalton's atomic theory. Dalton's atomic theory. British scientist John Dalton put forth in 1803 AD his celebrated atomic theory. According to him, matter is made up of extremely small, indivisible particles called atoms. Indivisible means they cannot be divided. It means you cannot divide atom. Atoms of the same element are identical in all respect, that is, shape, size, and mass. For example, all the oxygen atoms have same shape, size, and mass. A bundi laddu is formed by sticking smaller particles, that is bundis, to each other. It is found to have an internal structure. The atom, as described by Dalton, does not have any internal structure. According to him, atom is a hard, solid sphere with no internal structure, and the mass is uniformly distributed in an atom. Thomson's Plum pudding model. Sir Joseph John Thomson was a British physicist and Nobel laureate in physics. He made the groundbreaking discovery of electron. He demonstrated experimentally that the negatively charged particles present inside an atom have a mass 1800 times less than a hydrogen atom. Later, these particles came to be known as electrons. It is understood worldwide that atoms are electrically neutral. It means that the overall charge of the atom is zero. How is an atom electrically neutral in spite of having negatively charged electrons in it? Sir J.J. Thomson overcame this difficulty by putting forth the plum pudding model of atomic structure. The plum pudding model of atom put forth by Thomson in the year 1904 is the first model of atomic structure. According to this model, the positive charge is distributed throughout the atom and the negatively charged electrons are embedded or placed in it. The distributed positive charge is balanced by the negative charge of the electrons. Therefore, the atom becomes electrically neutral. Rutherford's nuclear model of atom. Rutherford's nuclear model of atom was devised by the New Zealand-born physicist Ernest Rutherford to describe an atom in 1911. Rutherford took a thin gold foil and bombarded or attacked the gold foil with positively charged alpha particles emitted by a radioactive element. Alpha particle is a fast moving particle which consists of 2 protons and 2 neutrons. It has a positive charge. Radioactive element. These elements are unstable isotopes that release subatomic particles or energy as they decay. We are going to study about this later in this chapter. Rutherford also used a fluorescent screen around the gold foil. Fluorescent screen is a transparent screen coated with a fluorescent material to show images from X-rays. The fluorescent screen was used to observe the path of alpha particles around the gold foil. When the alpha particles were bombarded on the gold foil, it was expected that the alpha particles would get reflected from the gold foil if the positively charged mass were evenly distributed inside the atom as put forth by J.J. Thomson. Means, if we consider J.J. Thomson's plum pudding model of atom, which is made up of positively charged particles distributed all throughout the atom and negatively charged particles embedded in it, then the X-rays would have reflected back after striking the positively charged particles. But that didn't happen. Most of the alpha particles went straight through the foil. A small number of alpha particles got deflected. Deflected means the particles changed the direction from the original path through a small angle. A still number of alpha particles got deflected through a large angle, and surprisingly, one alpha particle out of 20,000 bounced back in the direction opposite to the original path. The large number of alpha particles that went straight through the foil indicates that there was no obstacle in their path. It means that there must be an empty space inside the atoms in the solid gold foil. The small number of alpha particles that get deflected through a small or a big angle must have faced an obstacle in their path. It meant that the positively charged and heavy part causing obstruction would be in the center of the atom. From this, Rutherford put forth a nuclear model that you can see on the left side of the screen. Bohr's stable orbit atomic model. Niels Bohr was a Danish physicist who made foundational contribution to understanding atomic structure. He explained the stability of atom by putting forth stable orbit atomic model. The important postulates of Bohr's atomic model are as follows. The electrons revolving around the atomic nucleus lie in the concentric circular orbits at certain distance from the nucleus. These orbits are also called as shells or energy levels. They are stationary, means they do not move. Orbits are like paths on which the electrons move. Second, energy of an electron is constant while it is in a particular orbit. It means when electron is revolving in a particular orbit, its energy does not change. Third, when an electron jumps from an inner orbit to an outer orbit, it absorbs energy equal to the difference of its energy level, and when it jumps from an outer orbit to an inner orbit, it emits energy equal to the difference of its energy level. It means the change in energy occurs when the electrons jump from one energy level to another. The different energy levels are denoted by numbers 1, 2, 3 and so on. They are also represented alphabetically as K shell, L shell, M shell and N shell. Some more atomic models were put forth after Bohr's atomic model. Atomic structure was studied at depth with the advent of a new branch of science called quantum mechanics. Atomic structure. Atomic structure refers to the structure of an atom. An atom is formed from nucleus and the extranuclear part. This contains three types of subatomic particles. First is nucleus. Nucleus is a small dense region in the center of an atom. The atomic nucleus is positively charged. The entire mass of an atom is concentrated in the nucleus. The nucleus contains two types of subatomic particles together called nucleons. The subatomic particles are smaller than atom. Protons and neutrons are two types of nucleons. Second, proton. Proton is a positively charged subatomic particle in the atomic nucleus. Protons carry positive charge of +1 e or 1 elementary charge and a mass slightly less than that of a neutron. The total number of protons in the nucleus of an atom is the atomic number of that element. It is denoted by Z. Mass of one proton is approximately equal to 1 Dalton. Third, neutron. Neutron is a subatomic particle which is electrically neutral or has no charge. It is denoted by the symbol small n. It is found in the nucleus of every atom except that of simple hydrogen. The mass of neutron is approximately 1 Dalton, which is almost equal to that of a proton. Fourth, electron. Electron is an extranuclear part of an atom. It is negatively charged subatomic particle. It is denoted by small e. It has negative 1 elementary charge, that is -1 e charge. Mass of electron is 1800 times less than that of hydrogen atom, and hence mass of electron is considered negligible. Electrons revolve around the nucleus in an orbit. The orbit is also called as shell, which we studied earlier. The number of electrons in the extranuclear part is equal to the number of protons. Since the mass of electron is negligible, the mass of an atom is mainly due to the number of protons and neutrons in the nucleus. The number of electrons in the extranuclear part is equal to the number of protons in the nucleus. Therefore, electrical charge are balanced and the atom is electrically neutral. The total number of protons in the nucleus of an atom is called atomic number. It is denoted by the symbol Z. The total number of protons and neutron in an atom is the atomic mass number of that element. The mass number is denoted by the symbol A. The convention to denote atomic symbol, atomic number and mass number is given on screen. You can see how an element is denoted according to atomic symbol, atomic mass and atomic number. Then you can also see I have calculated atomic mass of carbon. Atomic mass is actually the number of protons plus number of neutron. Carbon has 6 proton and 6 neutron. When you add them, you will get the atomic mass of carbon, which is 12. Let's do some numericals. First is atomic number of carbon is 6. How many electrons are there in carbon atom? Students, we have studied that the atomic number of an atom is nothing but the number of protons present in an atom. So, if carbon's atomic number is 6, then the number of protons in carbon is also 6. We also studied earlier that the number of electrons and the number of protons in an atom are equal. So, if carbon has 6 protons, then carbon will also have 6 electrons. Second, the atomic mass and atomic number of calcium are 40 and 20 respectively. Calculate the number of neutrons present in calcium atom. So the atomic mass of calcium is 40 and atomic number is 20. So you can calculate neutron by the formula atomic mass minus atomic number. So it will be 40 minus 20. So the neutrons present in calcium are 20. Distribution of electrons. According to Bohr's atomic model, electrons revolve in a stable shells or orbit. These shells have definite energy. The shell nearest to the nucleus is the first shell, that is the K shell, The next shell is called the second shell, that is the L shell, and so on. The symbol N is used for the number of shells. The shells are also associated with numbers. Now, the number of electrons in a shell can be obtained by the formula 2n square. Let's see how it is done. K shell is the first shell, so n will be 1. We will substitute the value of n in the formula 2n square and we will get the answer 2. It means that in K shell only 2 electrons can be added. We cannot add more than 2 electrons in the K shell, that is the first shell. Now let's move on to the second shell, that is the L shell. In L shell, the value of n is 2. We will substitute the value of n into the formula 2n square and we will get the answer 8. So it deduces that in L shell only 8 electrons can be added and not more than 8. Similarly, by using the formula 2n square, in M shell only 18 electrons can be added and in N shell only 32 electrons can be added. Electronic configuration of elements. It is the distribution of electrons of an atom. In distribution of electrons, we studied that 2, 8, 18, 32 electrons can be accommodated in the shells K, L, M and N respectively. This is the maximum capacity of shell. The electrons are distributed according to the maximum capacity of the shell. Each electron in a particular shell has a definite energy. Energy of electrons in the first shell, that is K shell, is the lowest. But as you go further, the energy of electron in the subsequent shells goes on increasing with the increasing number of shells. The electronic configuration in the numerical form contains numbers separated by commas. Here, the numbers show the electrons present in the shells with increasing order of the energy. Let's take example of sodium atom. The atomic number of sodium is 11. It means that it has 11 electrons. We have to divide these 11 electrons in the shells. We know that in K shell only 2 electrons can be added. So K shell has 2 electrons. Now 9 electrons are remaining. We have also studied that in L shell only 8 electrons can be added and not more than that. So out of the remaining 9 electrons, we will add the 8 electrons in the L shell. Now only 1 electron is remaining. In M shell, 18 electrons can be added. So the remaining 1 electron will be added in the M shell. Hence the electronic configuration of sodium is 2, 8, 1. Let's take another example of hydrogen. Hydrogen has 1 electron. So this 1 electron will be easily added in the K shell. Next example is chlorine. Atomic number of chlorine is 17. It means it has 17 electrons. In the K shell, 2 electrons will be added. In the L shell, 8 electrons will be added and the remaining 7 electrons will be added in the M shell. So the electronic configuration of chlorine is 2, 8, 7. Valency and electronic configuration. Valency is the combining capacity of an atom. The number of chemical bonds that an atom can form as a part of a compound is called the valency of an atom. Chemical bonds is an attraction between atoms or molecules that helps in the formation of chemical compounds. It is actually a physical phenomenon of chemical substances being held together by attraction of atoms to each other. Water is a compound, that is H2O, which has formed where one oxygen and two hydrogen molecules are attracted or bonded to each other. Atoms form chemical bonds by using electrons of its outermost shell. Outermost shell means the last shell of an atom. Valency is determined by the number of electrons present in the outermost shell. The outermost shell is called the valence shell. The electrons present in the outermost shell is called valence electron. Example, sodium. Atomic number of sodium is 11 and its electronic configuration is 2, 8, 1. In sodium, M shell is the outermost shell and hence it is also called as the valence shell. It has one electron in it and that one electron is called valence electron. Valency of an electron is related to the valence electron of an atom. Electron duplet and octet. Let us study this by taking two elements, helium and neon. Helium has atomic number 2 and its electronic configuration is 2, where 2 electrons are easily added in the K shell. Helium has only K shell and it is also the outermost shell. This indicates that the outermost shell of helium is completely filled by the 2 electrons and we cannot add any more electrons to it. Hence it is said that helium has a complete electron duplet. Neon. The atomic number of neon is 10 and its electronic configuration is 2, 8, where 2 electrons are in K shell and 8 electrons are in L shell. L shell is the valence shell of neon and we know that the capacity of valence shell is 8. So it is said that neon has electron octet. From this it is understood that the valency is 0 when electron octet or duplet is complete. The electronic configurations of elements other than inert gases show that they do not have electron octet or duplet, or their electron octet or duplet are incomplete. Example, hydrogen. Hydrogen has only one electron which is present in K shell. It is short of one electron to complete a duplet. Atoms of all these elements except inert gases have tendency to combine with each other, meaning that they have a non-zero valency. Isotopes. Isotopes are elements which have same atomic number but different mass number. This is because the number of neutrons in the elements are different. We have studied that the total number of protons plus neutron in an atom is the atomic mass number. For example, carbon has 6 protons and 6 neutrons, so its atomic mass is 12. But in isotopes of carbon, the number of neutrons is different. For example, one isotope of carbon has 6 protons and 7 neutrons. Therefore, the atomic mass number of an isotope of carbon is 13. On the screen, you will see the isotopes of carbon and hydrogen. Uses of isotopes. Isotopes of some elements are radioactive. They are used in various fields such as industry, agriculture, medicine, research field, etc. Uranium-235 is used for nuclear fission and production of electricity. Some radioactive isotopes like cobalt-60 are used in the medical treatment of fatal diseases like cancer. Iodine-131 is used in the treatment of goiter. The radioactive isotopes are used for detection of cracks in the underground pipes. Example, sodium-24. Radioactive isotopes are used for food preservation from microbes. The radioactive isotope C14 is used for determining the age of archaeological objects. Nuclear reactor. Nuclear reactor is a machine that generates electricity on a large scale by using atomic energy. They are the heart of the nuclear power plant. In a nuclear reactor, the nuclear energy in an atom is released by bringing about nuclear reactions on the nuclear fuel. Nuclear fuel is a material used in nuclear power station to produce heat to power turbines, which in turn will produce electricity. The nuclear fuel used in this reaction is uranium-235. It is an isotope of the element uranium. Uranium-235 is bombarded or attacked with slow-speed neutrons. The nucleus of isotope uranium-235 undergoes nuclear fission. Fission means splitting or division to form nuclei of two different elements, krypton-92 and barium-141, and 2 or 3 neutrons are also released. If these neutrons hit other uranium-235 isotope, then more fission takes place. This is a continuous reaction and hence it is called chain reaction. Large amount of nuclear energy is released. The chain reaction are kept under control to prevent the probable explosion. To do this, some provisions are made. First, moderator. Moderator is a medium that reduces the speed of neutrons. In this case, graphite or heavy water is used. Second, controller or control rods. They are used to control the fission rate of uranium. They are also used to reduce the number of neutrons by absorbing them. Rods of boron, cadmium, beryllium, etc. are used as controller where they absorb the neutrons. They control the rate of thermal, that is heat output, and the rate of steam production. The heat produced in the fission process is taken out by using water as coolant. Water is transformed into steam. By means of this heat, turbines are driven and electricity is generated. In India, total 22 nuclear reactors in 8 places are functioning. Apsara at Bhabha Atomic Research Center in Mumbai is the first nuclear reactor in India, which went critical on 4th August 1956. India also has large reserves of the element thorium-232. I hope you have understood this lesson. Thank you.